Okay, today we're going to be starting the first lesson in Chapter 2, Relations and Functions. So we're going to be talking about different kinds of functions, modeling functions, and we're going to discuss the domain and range of functions. So previously we've identified domains and ranges for given situations. And now we're going to analyze relations and functions, and we're going to use equations of relations and functions. Our new vocabulary: we're going to learn what a one-to-one function is, what an onto function is, a discrete relation, a continuous relation, and you already know about the vertical line test. And we're going to discuss independent variables and dependent variables and how to write function notation. In your textbook on page 61 is a key concept. And this is where we learn about one-to-one functions. Each element of the domain, which would be our x value, pairs to exactly one unique element of the range. So notice that each of the x values has its own unique y value, or each domain has a unique range. That means it's one-to-one. Now it's onto, and this is where we work backwards. We're going to start with the range, and each element of the range corresponds to an element of the domain. Now if it's both one-to-one and onto, notice that each domain has one range. Everyone's unique, straight across. That's the difference. So if you need to take a moment and pause the video and study that concept, go right ahead. So let's look at example 1. They want us to state the domain and range of the relation. Now a relation is just a bunch of ordered pairs. This is a relation. And then they want us to determine whether that relation is a function, and if it is a function, we have to determine if it's one-to-one, onto, both, or neither. So first of all, the relation is made up of pair 1, 2, 3, 3, 0, negative 2, negative 4, negative 2, and negative 3, 1. Now the domain is just all those x values, and we're going to list them in least to greatest order. So negative 4, negative 3, 0, 1, 3. Those are all the x values that are in this relation. And the range is all the y values that's in the relation. And if there's one listed more than once, you only list it once when you're stating the domain and range. Each member of the domain is paired with one member of the range, so this relation is a function. So 1 gives a 2, okay, 0, negative 2, negative 4, negative 2. It is onto, but it is not one-to-one. They don't each have their own individual. Now I want you to state the domain and range of the relation shown in this graph and tell me, is it a function? So pause for a moment and check out the answers and choose the best answer. Okay, the domain is listed in the range, and yes, it is a function. Now we've talked about the vertical line test. If there's no vertical line that intersects the graph in more than one point, the graph represents a function. So notice if you draw a vertical line anywhere on this graph, it doesn't cross it twice. However, this one, it does cross twice, so this graph does not represent a function. This one does. So we're given a word problem. I'm going to let you take just a moment to read it, so if you'll pause the video for a moment. Okay, so we are to determine if this relation is discrete or continuous. Now a continuous relation, if you can draw the graph of a relation without lifting your pencil from the paper, then that one is continuous. So we draw our graph, our years, usually time goes across the bottom, and this little insignia right here denotes that there's a break. We've got a 0 here, but it skips a few. It's like 1, 2, skip a few, 99, 100. Did you ever count that way when you're little? So here we're starting at 0 and we skip a few and we're starting at 20.6. That way you don't have to use so much paper. So we're plotting our points. So use the vertical line test. Notice that no vertical line can be drawn that contains more than 1 point. And we can use these bar lines here. As we notice, it doesn't go through more than 1 point on the graph. So this relation is a function. Because the graph consists of distinct points, the relation is discrete. So it's just a bunch of points. It's not a line that's drawn all together. So this one was discrete. Now I want you to check your progress. Pause the video for a moment and work this problem. So, is this relation a function or not? Which one of these graphs looks like yours? Hopefully it's A. And this also is a discrete function. Notice that they're just distinct points. But they passes the vertical line test, so this one is a function. Good job. Now we're to graph a relation. So they give us this equation, y is equal to 3x minus 1, and we are to determine the domain and range. Then determine whether the equation is a function, is one-to-one, onto, both, or neither. And then we're to state whether it's discrete or continuous. So let's take a look at this. The first thing we want to do is make a table of values. So just like you could choose at least 3 values for x, substitute it up into the equation to determine what your y is. So they chose -1, 0, 1, and 2. Those tend to be my favorites also. So if you put a -1 in for x, 3 times -1 gives you a -3, minus 1 is -4. What do you get when you put a 0 in? Awesome, a -1. How about if you put a 1? You'd have 3 minus 1 is 2. How about if we put a 2 in? 6 minus 1 is 5. So now we have some ordered pairs that we can graph. Very good. There's our 4 points. Can you tell me, does it pass the vertical line test? Is it discrete or continuous? Oh, that makes a difference, doesn't it? We're graphing that line. How about the domain and range? Let's talk about that a minute. The domain are x values. We've discussed that before. Now, if this keeps on going this way and the line keeps on going this way, are there any limitations on x? Could you pick any point? Yeah, when it keeps on going, it's all real numbers for the x. How about y? Is there any limitations? Nope, it'll keep on going, won't it? All real numbers for y as well. So the domain and range are both all real numbers. Determine whether the relation is a function and state whether it is discrete or continuous. Well, this graph passes the vertical line test, and every x value is paired with exactly one unique y value, and every y value corresponds to an x value. So this equation is a function. It is both one-to-one and onto, and since the domain and range are both all real numbers, it is continuous. Time to check your progress. If you were to graph this linear equation, which one of these would match? Awesome. This is where it crosses the y at a positive 5. 1, 2, 3, 4, 5. And our slope is a positive 2 over 1. So we could go down 2, left 1. Notice those are both negative directions, so a negative over a negative gives us positive. Down 2, left 1, it crosses again. Down 2, left 1, so this is the correct one. Oh, now we get to evaluate a function. These are sort of fun. Now, something I want you to notice. This is what's called function notation. Notice it says f and then x in parentheses. This doesn't mean f times x. This is function notation. It's read f of x. And all we're simply doing is substituting f of x in place of where we normally had y. So f of x and y are interchangeable. And we're using f of x because now we're going to evaluate this function if f is -2. So we start with our original function, and now we're going to find f of -2. So all we have to do is substitute a -2 everywhere we see an x. So -2 to the third power is -8. -8 minus 3, that's -11. So f of -2 is equal to -11. Now you've done function notation. How about that? That wasn't too bad, was it? When an equation represents a function, the variable, which is often x, with values making up the domain, it is called the independent variable. The other variable, often y, is called the dependent variable because its values depends on x. Okay, so the value we found, f of 2, it depended on what we found for x. Okay, so let's look at this one. Now we've got a function, f of x is equal to x to the third minus 3, and we're to find f of 2t. So we write the original equation. We're going to substitute in a 2t. We're going to find f of 2t, and that's equal to 2t to the third minus 3. Well, 2 to the third power is 8, and t to the third power is t to the third. You see how we found that one? So 8t to the third minus 3. Can we combine these? Are these like terms? Nope, we cannot, because this one has t to the third and this one doesn't have a t to the third. These are not like terms. So this is our answer. That's as far as we can go. Okay, I want you to pause a moment and check your progress. Solve this one. Okay, if you were to put a -1 in for x, so f of -1 is equal to -1 squared. What's -1 squared? -1 times -1. That's going to give us a +1 plus 5. We get 6. Good job. You did so well on that one. Let's try another one. Let's find f of 3a. So pause for a moment and find your answer. Very good, 3a squared, so 3 times 3 is 9, a times a is a squared plus 5, and that's as far as we can take it. Okay, you're ready to begin to work the problems. Good job, folks.